This video is for section 9.3. Our objectives in this section are to change from logarithmic to exponential form and exponential to logarithmic form, evaluate logarithms, graph logarithmic functions, and use common and natural logarithms. So obviously this section is all about logarithms, and we need to start by defining what a logarithm is. So a logarithm is a way of rearranging an exponential function. And that's very important to keep in mind as you're working with them. So if I write logarithms have a base, which is written in what's called subscript notation, which is kind of lower and smaller. Log base b of x equals y. So there's three numbers in a logarithm. In exponential form, I would have b, the base, to the y equals x. So the answer to the logarithm is the exponent. So what you want to do is look at this and make sure that you understand where all three numbers are going when we write something in logarithmic form from exponential form. The b is the subscript, the answer to the exponential equation comes next, and the answer to the logarithm is the exponent. So we have kind of this circular process. You'll see an image of this in the book. B to the y equals x. So we're going to look at example 1. This is rewriting logarithms into exponential form. So I'm going to use the arrows here. 5 to the second power equals x. It's usually helpful, I think, to start with the base. For part B, it's going to be start with the base b. The exponent is 3, so b to the third, and then that's going to equal 64. And then for part C, this one is written the other way around with the log coming on the left side of the equal sign, but it's the same idea. I'm going to have 3 for the base, y for the exponent, and then that's going to equal 7. So notice here I have variables in these answers. Like in part A, I know that 5 squared is 25, but what they're asking you to do here is not solve anything, it's just to rewrite it in exponential form. So your answer should still have 3 either variables or numbers in it. We're going to get to solving a little bit later, but for right now we're just rewriting, so you should have a base and exponent equals something in your answer. So next you should look at checkpoint problem number 1. Do this in your notes, check your answer in the notes that are posted, and then move on with the rest of the video. Next we're going to look at example 2, which is going in the other direction. Now I have exponential form equations, and I'm going to rewrite them into logarithmic equations. So again, what I like to do is start with the word log and identify the base first. Base has the exponent attached to it, so this base here is going to be 12. And then what's going to come next is the answer side of the exponential equation, which in this case is x, and that's going to be equal to the exponent, which is 2. The answer to a logarithm is always the exponent. For part B, write the word log, identify the base, which is b, then the 8 is going to come next, and then the answer to the logarithm is the exponent, which is 3. Part C, write the word log, identify the base, in this case it's e, What's going to come next is the number 9, and it equals the exponent, which is y. Now for this one, you'll see in the notes there's another way to write it, and we're going to talk about that a little bit later, but log base e has its own special notation that you'll see. But for right now, you can just write log base e of 9 equals y. So next you should look at checkpoint problem number 2. Do this in your notes, check your answer, and then move on with the rest of the video. Next, we're going to look at example 3 where we're actually going to evaluate logarithms. So we're going to find what number goes on the other side of the equal sign. And for right now, we're going to do this kind of by just guess and check and hand type of methods. We're going to talk about how to do these on a calculator a little bit later. So what I want to think about here is, again, rewriting this in exponential form. So my base is going to be 2. The exponent is what I'm going to be looking for so that it equals 16. So in other words, what I want to ask myself is 2 to what power equals 16? And you can again do this kind of by guessing and checking on your calculator. 2 to the third is going to be 8. So 2 to the fourth is going to be 16. So the answer to my logarithm is 4. Same process for part B. It's going to be 3 to what power equals 9? Well, I know that 3 squared equals 9, so the answer is going to be 2. There's a part C to this, which you'll see in the book has an answer for a fraction. You don't have to worry about that for this class. We're not going to do any logarithms by hand where the answers are fractions. So you can do checkpoint problem number 3, and just do parts A and B. Do this in your notes, check your answer, and then move on with the rest of the video. Lastly here, we're going to look at example 4, and this is going to be using the same process that we just used in example 3. But these are special types of logarithms. So we'll see in part A, we're doing 7 to what power equals 7? Well, if you have the same number here, then that means that the power is going to be 1, because any number to the first power is equal to itself. So in your logarithm, there's nothing special about the number 7. If I have the same number for the base as the number after it, the answer would always be 1. And the book kind of presents this as like a property or something that you can remember. I don't think that you have to memorize this. I think that if you just can always think about rewriting the logarithm in exponential form, then you can get the answer of 1 because you know that any number to the first power is equal to itself. For part B, the question here is 5 to what power equals 1? Well, if it equals 1, it's any number to the 0 power is equal to 1. So the answer here would be 0. So if I have any number here as the base and the next number is 1, the answer would always be 0 because any number to the 0 power is equal to 1. So next you should do checkpoint problem number 4. Do this in your notes, check your answer, and then you can do the homework for this section.